Hello and welcome to this Python tutorial. Today we will discuss operators. Okay, operators are something which operates on data. Okay, now let's see what are operators. Uh, Operators are special symbols which perform operations on variables. We have discussed the variables in previous lecture. If you haven't, please go and visit those variable lectures. Okay. Now let's here you can see a equals to 3. Okay. Here b equals to b is assigned a value 4, C is assigned a value 2, and D is assigned a value A plus B into C. Here, all these symbols marked in yellow are operators. Okay, uh, and those which are marked with red are operands. Operands are, you can say them as a variables. Okay, so if I want to perform operations, okay, if I want to just add, if I just want to add the a plus b into c, so we need operators, okay, so that they can perform operations on these variables. So finally I can get final addition and multiplied results. Okay, so this is all about what are operators and what they do. Okay, so why operators? Operators are needed to perform operations on variables. Okay, uh, so okay, now let's evaluate this equation. Okay, how you will evaluate this? Will you first add, or, will you multiply? Okay, will you just do 3 into 4 like what I did here? 3 into 4, it will become 12, and then add with 2, or you will do first add 2 plus 3 and then multiply it with 4. Okay, we all know this is wrong due to Bodmas rule. Okay, whenever we solve these type of equations manually, mentally, we will use Bodmas rule. Okay, but in programming, the computer won't use Bodmas rule. Okay, so you may be wondered what it will use. Okay, now let's see. You can see computer never use Bodmas rule. That's why I mark this as wrong. Okay, and this is wrong. Okay, according to Bodmas rule and the rule which computer uses also. Okay, so the computer uses a rule of precedence. Okay, here you can see the precedence of multiplication operator is greater than the precedence of plus operators, and last is the precedence of assignment operators. Remember one thing, in programming we will never call this as a equal to. Okay, we will always call this as assignment operator. So here you can see first 3 is multiplied by 4 because in this whole equation uh, the precedence of multiplication is greater. So 3 into 4 uh, and it will become 12. Then the next precedent is of plus. So we will add 2 plus 12 and it will become 14, and the last precedence is of assignment operator. So finally D is assigned a value of 14. Okay, this is how program in a computer evaluates a equation. Okay, now let's move forward. There are basically six types of operators in a programming language. Okay, first is arithmetic operators. Okay, then bitwise operators, then relational operators, logical operators, conditional operators, and finally assignment operators. Okay, these operators have precedence. Okay, sorry. So uh, highest, so arithmetic operator have the highest precedence. Okay, so whenever a equation is written and where a arithmetic operators come, you have to first evaluate arithmetic operators, okay, then bitwise, relational, then logical, and finally in the end comes assignment operators, which has the lowest priority. Okay. Now let's see what are arithmetic operators. Arithmetic operators are used to perform mathematical operation like addition, subtraction, which we have seen in the first slide. Okay, addition, subtraction, multiplication, and division. Here is a table. Okay, uh, table. This is a multiplication symbol. Okay, uh, star. Okay, this is used for multiplication, this is used for division, this is modulus. Okay, this is used for finding remainders. No need to worry about this. I'll explain this in detail when I go forward for explaining for loops and while loops. So there we have uh, a real application of this, that you'll understand this in better. Okay, so now let's just take example. If I write 5 modulo 3, then what will be the remainder? It will be 2. So if I write 5 modulus 3, the answer will become 2. Similarly, if I write 8 modulus 4, the answer will become 0, because in this case the remainder is 0, and in the previous case 5 modulus 3, the remainder is 2. Okay, yeah, and you all know about plus, minus, so there is no need to explain these all in detail. Okay, now let's move forward and understand the precedence inside the arithmetic operators. Okay, I have explained these plus, division, and modulus have same priority. Whenever they are written in a equation, they have same priority, and the priorities of a plus and minus are same. Okay, and the priorities of plus, division, and modulus are greater than the priorities of uh, plus and minus. Now you may be wondering, if these all operators, means suppose these three operators are written in equation, then they have same priority. So what? From where should I start? Okay. Now let's see this expression. How to evaluate expression with same priority? Okay. Here plus comes after. Okay. So we will evaluate this thing afterwards, because this thing has the greater priority. So now what will you do? Will you multiply 5 into 4, or divide 4 by 2, or modulus of 2 and 4? Okay, I cannot do like this. Okay, so there is a rule. Okay, this is called as use associativity rule. Okay, this rule, from this rule, for same precedence, okay, where there is the same priority, there we have to use associativity rule. Let's understand this associativity rule. Okay, evaluate in this type, what associativity rule says, that it says that when these type of equation comes in, we have to start evaluating from left to right. Okay, so as here it's pressed, so we'll evaluate this later and this also later. This whole thing has top priority, but in this all have same priority. So we have to start evaluating from left to right. So first we will evaluate this. Okay, means we will evaluate this multiple symbol. Okay, so it will become 20. Okay, now we will evaluate this divide symbol. Now it will become 10. Now we will evaluate this modulus. Okay, and here the answer will come 2. Here the answer is 2, because 10 modulo 4, because the remainder is 2. Okay. Now finally the plus. Okay. And the final answer will become 9. Okay. This is how we will apply associativity rule, and here what is associativity rule I have explained. Okay. Let's move forward. Now let's start with bitwise operators. Okay, bitwise operators act on bits and perform bit by bit operation. You might be worried what are bits. Okay, no need to worry. I have uploaded, I have provided some YouTube links for understanding of bitwise. So if you don't know what are bits and how to convert a decimal value into binary values, or vice versa conversion of a binary value into a decimal values. Okay, so I have provided links. If you don't know, first go and visit those YouTube links, and then start watching this. Okay, if you know, you can continue with this. Okay, so these are a few bitwise operators. First is bitwise in, second is bitwise or, then bitwise not, bitwise XOR, bitwise right shift, bitwise left shift. Okay. So you just note down all these things because we might use these things in future. Okay. So bitwise n. If in this table shows that if x has a value 0 and y has a value 0, then bitwise end of x and y is 0. Similarly, for if x is 0, y is 1, its final answer will be 0, and if x is 1, y is 0, bitwise output is 0. For 1 and 1 it's 1. Okay, now let's see. There are two decimal values are given, x equals to 23 and y equals to 56. Okay, and z equal, and now we have to evaluate x bitwise y. Okay, so here you can see I have written x equals to this. I have converted this 23. This is a decimal value. I have converted this into a binary value and I have written this here. Now here this by I have converted 56 into a binary value and I have written this here. If you have any confusion, you can go and visit a YouTube video which I have provided in the articles. Okay. So now let's see how this bitwise work. Okay, here. So you can see 1 and 0. Okay, now 1 and 0. Now go and visit this table 1 and 0. What's the output? What's the final output of this operation? Is 0. So here it comes 0. Similarly, for again 1 and 0, 0 comes, 1 and 0, 0 comes. Okay, now 0 and 1. Now this here you can see 0 and 1 is 0. So here also 0. Okay, now you can see 1 and 1. So let's find 1 and 1. This one and this one. Okay, now what's the output is 1. Okay, so here also 1 comes, and similarly again 0 and 1, and this here will come 0 because here 0 and 1 is 0. Okay, so finally this is what is in binary. Now I have to convert this into decimal. If I convert this into decimal, the output will come as 16. So finally the bitwise end of 23 and 56 is 16. Now let's see bitwise OR. Okay, uh, bitwise OR. Here bitwise OR has different table. Okay, so you just only note down these tables because this will help you. Okay, so now for 0 and 0, you can for OR you can consider it as plus. Okay, so what will happen if I just add 0 and 0? It will become 0. Okay, if I add 0 and 1, it will become 1. This is a technique for learning. Okay, for OR. Okay, if I add 1 plus 0, it will become 1. Okay, and what if I add 1 into 1? Okay, it's 2, but consider it as 1. Okay, this is the technique to learn. Okay, you don't have to always memorize this. Okay, so now let's perform bitwise operation on again bitwise OR operation. Okay, again this I have explained previously, converted into from 23 converted from decimal to binary. Okay, 56 converted from decimal to binary, and I have written here. Now perform OR operation. What is 1 and 0? You can see 1 and 0 is 1. So I have written here 1. Again 1, again 1 and 0. what it is? 1. I have written here 1. Similarly, again 1 and 0, 1. Again for 0 and 1, for 0 and 1, what it is? 1. So I have written here 1. Okay. Now 1 and 1, what is 1 and 1? It's 1. So I have written here 1. Now for 0 and 1, it's again 1. 1. So I have written here 1. And for 0 and 0, it's 0. So I have written here 0. Okay. So finally, I got the uh, uh, binary output of x bitwise by. Okay. Uh, this is z is in the binary. If I convert this into decimal, this whole value into decimal, it will become as 63. Previously, when we performed AND operation, we got uh, 16 as the output. Okay. Uh, Now let's move forward and see uh, bitwise. Okay, I have written here bitwise OR. It must be bitwise XOR. Okay, you just change this. Okay, so now this is the table for bitwise XOR. You can see this is 0 0 is 0, 0 1 is 1. Okay, 1 0 is 1. Okay, and 1 and 1 is 0. Here whenever the same values come, 0. Okay, whenever different values come, it will become 1. Okay. Now again this you can see for 1 and 0. Okay, perform here I perform bitwise XOR operation on 23 and 56. Okay, and the final what I got is as 47. So 1 and 0, here what is 1 and 0 is 1, so I'll write here 1. 1 and 0, what is 1 and 0? Again 1 1. Similarly, okay, for 0 and 1, what is 1? For 1 and 1 it is 0. For 0 and 1 again 1. So finally I got the binary, and now I'll convert this into decimal. Okay, here we are doing here I have explained all these things so that you can understand, okay, what's going on. There is a code for doing all those things. Okay, no need to always here you don't have to learn all conversions. Okay, binary to decimal, decimal to binary. I have just explained so that you can understand what is happening in the background. Okay, there is a code for all this. Okay, now come to right shift operators. Okay, right shift, what will strike to your mind by right shift? Okay, right shift means it will shift bits to right side. Okay, now let's see this. Here 56, I converted this into binary, and this is the conversion of binary. Okay, when I'll shift this x by 2 towards right. Okay, so what will it do? It shifts all the bits towards right and add 0 in 0 in the beginning of the left. Okay, so here you can see the you can see these red ones and zeros that they got shifted towards the right side. Okay, so this is what a right shift operator will do, and if you convert this in this binary form into decimal, you will get as 14. Okay, now left shift operator, what left shift will do? Left shift shifts towards left side. Okay, so here you can see left side. Uh, Now what happened previously in right shift? I shift the bits got shifted towards right. It starts from here. Okay, what happened here? The bits got shifted towards left. Now the bits starts from here. Okay, here you can see these red ones and zeros got shifted here. So this is what happens. Okay. Uh, Now comes to relational operators. Relational operators always yields true or false values. Okay. Uh, uh, Now let's see. These are few relational operators: greater than, small, less than, greater than, less than, equal to greater than equal to okay. Here I had just made a mistake. This must be here and this must be here. Okay, corrected. Okay, this is not equal to and this must be equal to. Okay. This symbol we call it as equal to, and this we call as not equal to. It's not like that. Okay, here what we practically call as equal to is called as assignment operator in Python. Okay, and what and this is called as equal to. Okay, no need to worry how to write program for all this. I'll explain in the upcoming videos using loops. Okay, now logical operators. This is how these are logical operators. Okay, there are three types of logical operator. First is and, or, and not. Okay, not operators. Not operators. If you write if suppose x is true, and if you write not x, okay, if you use not operator in front of a boolean variable, it will return as false. It will return just the opposite values. Okay, if it is false, it will return true. Okay, not operator. Now let's see and operators. Okay, and operators is similar to what I say, bitwise and. Okay, just replace 0 with false and 1 with true. You will get the same output. Okay, as in bitwise and. Similarly, bitwise or in bitwise, or if you replace 0 with false and 1 with true, you will get the same table. Okay, so this is how and operator works, and this is how or operators work. Okay, now finally comes assignment operator, which has the lowest priority. So operators, this is called as assignment operators. Okay, so if x is assigned value 5, okay, this is equal to this. Okay, this is okay. You can write this. Okay, but if you search some program in Google, okay, if they use these kind of things, so you must know these kind of things, that this is this. Okay. Uh, you might be thinking that I can use this. Why should I learn this? Because sometimes programs are written in this way, using these type of conventions. So you must know all these things. Okay. So just take a glance, and no need to learn all these things. By practicing, you are able to apply this. Okay. So this is all about uh, operators. Okay, thank you, and have a nice day and enjoy learning Python. See you in next video.